So today we are going to continue with chapter 1. We're going to cover section 2. Today we are going to learn about measuring and constructing segments. Now, in this class, I am not going to require you to bring a compass or a ruler. We are not going to actually draw precise figures where we're going to be using a compass or a ruler. But just know that those would be the tools that you would use if you were to ever have to construct something precisely. So let's go ahead and take a look at what we have. The first thing we're going to talk about is using a number line. And we're going to find the definition of a coordinate. And a coordinate is a number that corresponds to a point. So in this particular number line, where it starts at A and goes to D, the coordinate of A is -2. It's always the number portion. 2 is the coordinate of D. When we want to find the distance from one point to another, what we're going to do is find the absolute value of the difference of the coordinates. Now, when you find the absolute value of a number, what we're doing is figuring out how far away is that number from 0. An absolute value always makes the number or the answer positive. So distance will never be a negative number. Now, if you're given a number line and they ask you how far away is point A from point D, technically all you have to do is count the gaps or the spaces. So here's A, here's D. If I want to know how far away it is, I could just go 1, 2, 3, 4 and see that it's 4 spaces away. However, let's say they didn't give me the visual and give me the number line, and all they gave me was this. Then what I'm going to do is apply this. And I'm going to find the difference of the coordinates and then find the absolute value. Now, you could either subtract the larger coordinate from the smaller or the bigger from the smaller, because it doesn't matter because you're finding the absolute value. So, for example, if you wanted to go from A to D, which is what they have here, A's coordinate, remember, was -2. D's coordinate was +2. So if you're going to subtract the bigger one, so if you do from D to A, you would do 2 minus -2 and then find the absolute value of it. Once you do this, you use your rules of integers that you learned in middle school, whether it was keep, change, flip, stay, change, change, whatever your middle school teacher taught you when you subtracted integers. This actually turns into 2 plus 2, which gives you 4. And then when you find the absolute value of +4, it's still +4. Now let's say you went the other way. Let's say you decided I wanted to subtract A's coordinate from D's coordinate. A's coordinate was -2. D's coordinate was 2. And notice once you subtract this, you get -4, but you're still finding the absolute value, which now makes that distance positive. So again, it doesn't matter what you subtract from what, you will still get the same distance. Next, we're going to define what a postulate is. And a postulate is just a statement that's accepted without proof. So in other words, it's a rule or definition. Later on, we're going to learn about theorems. And theorems need to be proven. But that'll be coming up in another lesson. So our very first postulate that we're going to learn about in this textbook is called the ruler postulate. And it states that the points on a line can be matched 1-to-1 with real numbers. So once you either create a coordinate system or a number line, the distance between any 2 points equals the absolute value of the difference of their coordinates. And this part that was right here is what we just saw on the previous slide. Now, for this course, I will never ask you to restate postulate 1 or postulate 10, because on a standardized test, an SAT or PSAT, they will never number a theorem or a postulate because every textbook publisher has different numbers for each of the postulates. It's not always set that number 1 is the ruler postulate. For our book, the way that they number it is how it's presented in the textbook. So because this is the first postulate we're learning about in our textbook, they've given it number 1. So you don't need to memorize the number. What you need to memorize is either the name of the postulate or what it states. Now let me just give you another example of finding the difference between, or the distance between two coordinates. So let me go ahead and add a little example down here to the bottom. I'm going to draw a number line. I'm going to add some coordinates to it. So -1, 0, 1, 2, and 3. And I'll add A, B, C, D, and E. So let's say they gave you the visual, and you can see that coordinate A is equal to -1, and I'm going to ask you to find the distance from A to E. So again, you could either, if you're given the visual, count the gaps, count the spaces. 1, 2, 3, 4. So by using the visual, we can see that there is a distance from A to E of 4. Now let's say I didn't have the visual and they just gave me this, then that's when I can apply this rule of subtracting the coordinates and then finding the absolute value. So if I were to do E minus A, I would have been doing 3 minus, and then A was a -1. And then again, remember, you're going to find the absolute value. And this gives me +4, and the absolute value of +4 is 4. Let's say we didn't want to do the bigger minus the smaller. You could still do A minus E, and you would do -1 minus 3. That would give you -4, and then absolute value. And again, distance is never negative. So again, either graph it yourself on a number line or just subtract and find the absolute value. So the next slide has the definition of construction. And just understand that a construction is a geometric drawing that uses a limited set of tools. And those tools could either be a compass, a straight edge, in other words, a ruler, to draw a precise figure. Just understand the definition in case you ever see this vocabulary word described on an SAT or a PSAT. I will not be testing you on this vocabulary word or expect you to draw precise figures. But just know that this was something that's in our textbook, and just in case it shows up on a standardized test, I wanted to explain what construction means in terms of geometry. The term congruent means that when you have two objects or two figures, they're going to have exactly the same size and shape. So instead of referring to two shapes as being equal, they refer to them as being congruent. The symbol for congruent is an equal sign, and then it has like a little wave on top. That is your congruent symbol. So for example, if I were to refer to two triangles that were congruent, they would be exactly the same size and shape. When we talk about congruent line segments, we're talking about segments that have the same length. Now, one special rule that you need to think about when we're talking geometry is you can never assume anything about the size of something unless you're specifically told a definition or a rule or they've actually given you the length, or they've included congruency marks. So if I were to draw these two segments on my paper, just like this, with no other information, and you didn't have a ruler to measure them, and if I asked you, is AB congruent to CD? You would not be able to answer that question. You would say, not enough information. What you would have to look for is, let's say they told you that this had a length of 2, and maybe this one had a length of 2. So if they tell you how long it's supposed to be, then you could say that segment AB is congruent to segment CD. Remember, when you name a segment, you can name it with just the 2 capital letters like that, but a lot of times they will put the picture of the segment on top. Another thing you can look for are congruency marks. So when you have congruent segments, they might put what they call congruency marks or tick marks. And what they might put is like a little dash. And as soon as you can find another segment with the same type of marking, you can conclude that those segments are congruent when they have the same congruency mark. But without any marks or without any numbers, we can't assume that those two are congruent segments. The only thing you can assume in geometry is if they give you something that looks like this, you can say that that's a straight angle or a straight line. If they give you something that looks like an L, and I don't know if you guys are familiar with something that looks like this, generally when you have something like this, this is a right angle, but without this little box or without them telling us that it's 90 degrees, if it's just drawn like this with no markings or no numbers, I cannot assume that that's a right angle. It could be 91 degrees or 89. So they will have to give you more information than just the drawing of that something that looks like an L. Postulate number 2, and again, the number is not important to us. You can either use the name or what it states. Now, we will be using this second postulate quite often. We will be using it in our proofs. It is called the segment addition postulate. I like to abbreviate it. So because I'm going to probably use this postulate a lot, instead of having to write out segment addition postulate every time, I abbreviate it as SAP. I take the S from segment, the A from addition, and the P from postulate. And then when I have to write this as a reason or justify something I'm doing, I just put my acronym. If you want to abbreviate SEG or put the plus sign for addition, however you want to abbreviate it. But what you're going to see coming up, we will be using this quite often. And what this postulate states is that if B is between A and C, then AB, segment AB, plus segment BC is equal to segment AC. The converse of that is if they told you that AB plus BC equals AC, then you can conclude that B is between A and C. So let me give you a visual of what this all means. Now, this word between doesn't mean that B is right smack in the middle. It means that it's somewhere in between points A and C. So let's say I'm going to put point B right here. So what this postulate states is if this little piece here, AB plus BC, once I find the measurement of those two, I can add them together and it'll give me the length of the whole thing. So, for example, let's say that AB had a length of 2. And let's say BC had a length of 6. And I want to know how long is AC. So I'm going to use my segment addition postulate. I'm going to add AB, which is 2, I'm going to add that to BC, which is 6, and that's going to give me the length of the whole thing. So 2 plus 6, and the length of AC is going to equal 8. So when I give you little pieces, I can add them together to get the length of the whole segment. Now I could also work backwards. So let me write another example here. Let's say I have another segment. Now it's not always going to be A, B, C. It could be different letters. It could be X, Y, and Z. But notice Y is in between now. So let's say this time I gave you the length of the whole thing, and I told you XZ equals 5. And let's say I also give you that XY from here to here is a 1. And I want you to find the length of YZ. I'm going to call that X. So I know that I could take XY plus YZ and set it equal to get the whole thing. So if XY is 1 and I don't know YZ, now I can solve my simple algebraic equation by subtracting the 1, and I can see that X equals 4, and X represents YZ. So this little piece of my puzzle here, 4 plus 1 is 5. So by using this segment addition postulate, they can either give you the whole thing in one little piece and expect you to find the other little piece, or give you both little pieces and find the whole thing. Now, for my next one, instead of me giving you a segment and have it drawn, sometimes you're going to be given order pairs or coordinates, and you're going to have to graph them on a coordinate plane and then determine if they're congruent. Now, whenever the segments you draw are horizontal lines or vertical lines, you could get away with just counting the little boxes, as long as you're doing it on a nice, neat coordinate plane. Now, when you're doing the homework for this lesson, if they give you a question like this and a coordinate plane was not provided, you can create your own by using the background graph paper in Notability, or just finding a picture like I did on Safari and then put the picture in your Notability. But the notes have a coordinate plane, so let's graph the 4 order pairs. Now what they want me to check is JK, so I'm going to plot these 2 points, and then I'm going to connect them, and I'm going to get the length of that segment. So the order pair J, -3, +4. Remember, the first number in your order pair is your X, the second is Y. So the first one tells you how you move left or right, and then the second one up or down. So for J, I'm going to go over to the left to -3, and then up to +4. And that'll be J. K, and for K, I'm going to go to the right to 2 and up to 4. Connect the points. And now, you can either choose to use that formula, or in this case, since it's graphed on a nice, neat coordinate plane, I could count the little boxes, 1, 2, 3, 4, 5, and I can see that JK has a distance or a length of 5. Now, if you prefer to find the difference and then absolute value it, you can do that as well. Because what you're going to do is you're going to take the part of the order pair that is the same in both, and then these will be the 2 that you subtract. So you could do 2 minus -3 and absolute value it, and you get 5 this way as well. Next, I have to graph L and M. So L is the order pair 1, 3, and M is 1, -2. So it does make it a lot easier when you graph it, because watch, I could just count. 1, 2, 3, 4, 5. LM is 5. So because they both have the same length, I can say yes, JK is congruent to LM because they both have a length of 5. Now, if you also wanted to subtract L and M, L was 1, 3, M is 1, -2. Again, you can see the ones were the same. So now just subtract the y's, absolute value it, and you get 5 by finding the difference and the absolute value. So once you find the length of each one, if it turns out to be the same length, then you're going to say, yes, they're congruent. If they were different numbers, let's say JK was 4 and LM was 5, then you would state that they are not congruent. All right, next, we're going to fill in the blank with either the word sometimes, always, or never. Now, I know the lines are a little small, so for the sometimes questions, if you want to just put a capital S, for the always, a capital A, for the never, a capital N. It's up to you if you want to write out the word. So the first one, the length of a segment is sometimes, always, or never negative. Is the length of the segment ever negative? No, it's never negative. So either put a capital N or you could write the word never. The next one, if point S is between R and V, then S lies on segment RV. So if I give you a little visual, R and V, and if S is between, yes it does. It is always. Beautiful. I'll just put a capital A. Number 3, a coordinate can be blank, sometimes, always, or never, be paired with a point on a number line. And this is the ruler postulate, so it's always. Example 3, we're going to apply that segment addition postulate. This time, instead of just numbers, it's got expressions. So this is how we're tying in our Algebra 1 skills. So it tells us that J is between I and K. So let me go ahead and draw the segment IK and put J in between. So sometimes when a picture is not provided, it definitely pays off to give yourself a little drawing. So here's I. I'm going to place J right here and then K here. So it says that IJ, so from here to here, it's 2x. And then the next piece, JK, here to here, is 4x minus 6. And then they're giving me the length of the whole thing, IK, and they're telling me it has a length of 30. So I'm going to be using my segment addition postulate because I know that IJ plus JK is going to give me the length of the whole thing, IK. So I'm going to replace what they gave me. IJ is 2x, JK 4x minus 6, and then the length of the whole thing, IK, is 30. I'm going to be solving this multi-step equation. I'm going to be combining my like terms here. So 2x plus 4x is 6x. I'm going to drop down the rest of the problem. So the -6 or the -6 equals 30. And now I have a two-step equation. I need to add 6 first. 6x equals 36. Divide by 6. And x equals 6. And that was the first part of the question. Part B wants me to find the length of IJ. Well, I know at the beginning, they told me IJ is equal to 2x. So now I'm going to take what I just found x to be equal to, replace x with the 6, multiply 2 times 6, and the length of IJ is 12. For JK, exactly the same thing. They told me JK from the beginning was 4x minus 6. I'm going to replace x with the 6 that I found when I solve the equation, I'm going to multiply 4 times 6 and then subtract the 6. So the length of JK is 18. Now, once you do this, remember that these two added together should have equaled 30. So just to make sure your calculations are good, you could add 12 plus 18, these two answers. If it doesn't give you 30, then you've done something wrong. Now, technically, after I found IJ, I could have also done 30 minus 12 and found out that JK was 18. So there's multiple ways to do this once you find the individual pieces. So this is applying your segment addition postulate. So when you're doing your homework, if you are given problems where the segments are represented by expressions, I would like to see all of this work of how you make it into an algebraic equation and how you solve for x and then how you plug it back in. So I need to see calculations. Even though you may be using a calculator, I still need to see all the setup to give you full credit.